And now on to the part we're all waiting for. Today's presentation is Getting Started with Kubernetes by Nigel Poulton. Nigel is a techaholic with a passion for demystifying exciting technologies. He's written several best-selling books and video training courses and has helped well over 1 million people take their first steps with Docker and Kubernetes. He loves to connect with people, and you can reach out to him at nigelpoulton.com. He's also on most of the social media platforms at the Nigel Poulton handle. Nigel, without further ado, take it away. I'm super jazzed to have you talk with us today.
All right, cheers, Dom. Really appreciate the introduction. So hello, everybody, and welcome to the session. Listen, look, I really appreciate everybody's time. It's an exciting topic that we're going to talk about, but I am super keen to make the most of the time. I'm about to share my screen, so as I do that, you get to say goodbye to my ugly mush, which I don't know how well that translates internationally. It means you don't have to stare at my face. So I'm going to share my screen. Dom, if you don't see my slides, just shout up and let me know. I'll just take a second or so to get going now. All right, so I am sharing. So if that's not up in about 10 seconds, just holler. Oh, there we go. It looks good to me. All right, then. So getting started with Kubernetes. I've got one or two very quick housekeeping items myself as well, right? I know Dom's introduced me, but this is me. I'm Nigel. If you're curious about the accent, I am from the UK, not from Australia or South Africa or anywhere like that. I'm from the UK. Not that it matters, but some people are like, where is that accent from? I have written a bunch of books, not all on containers and Kubernetes, but my most recent books have been on those topics. I've kind of lived and breathed this stuff for almost as long as I can remember, at least 6, maybe 7 years now. In fact, maybe more. Anyway, never mind. Like you say, you can reach me at Nigel Poulton on Twitter and most of the other social platforms where, look, I don't talk about what I had for breakfast, but I am more than willing to talk about technology, especially containers and Kubernetes. Though I'm going to caveat it, right? Unfortunately, I can't be free technical support because although I have written books and done video training courses and stuff, and apparently they are pretty good, it doesn't mean that I know everything. And I do occasionally, or more than occasionally, get people will message me with really complex problems that I think it would take a team of engineers like a week to solve. And people sometimes think because I've written a book or two that I can just answer it like that, and I can't. But look, I'm more than willing to help people get started, and if they're stuck on a few things, that's cool with me, okay? But really complex stuff, I'm just kind of a bit too busy. Also, though, right, Dom has mentioned, look, please, please, please ask questions. Look, I would much rather we could be meeting in person at an event where we can bump shoulders in the corridor or meet up with a coffee machine and ask questions and stuff like that. But that's not the case. We're doing this virtually. We can make it super interactive, though. And one of the big ways of doing that is by you guys asking questions. Now, I'm setting this up, right, as a super safe space. And what I mean when I say that is, look, I promise you, there are no silly questions. So if you have a question and you're unsure whether or not you're brave enough to ask it, please just ask the question. You won't be the only person that isn't sure about whatever you're asking about. There'll be a bunch of others on the call that think the same. Be brave and ask the question. I'll kind of make an agreement with you here, right? Look, some of the questions that you may ask, I might not know the answer to. And I promise I won't be embarrassed to hold my hand up and say, I don't know the answer to that question. But I want you to promise to me that if you have a question, you'll be brave enough to ask it. So you be brave enough to ask, and I'll be brave enough if I don't know the answer. And kind of like these sessions are a bit boring if you don't ask questions, because you end up just listening to me talk to a few slides for 45, 50 minutes, whatever it is. So crack on with the questions. Like I say on the slide, it is the law. Anyway, this is kind of what we're going to cover. We are talking about getting started with Kubernetes, right? There's a bunch of theory and sort of concepts you really have to wrap your head around first, though, before you can start your kind of journey with containers and Kubernetes. So we will spend a bit of time sort of demystifying some of the fundamental jargon. But we'll talk about what is a container, maybe how it, well, actually, yes, how it varies from a virtual machine. What is Kubernetes, why it's important, how it impacts you, right? And there, I mean, how does it impact you as an individual, so your own personal career, but how does it also impact the kind of organizations and teams that you work with? And then we'll talk about a few quick ways of how you can maybe get your hands on and start pressing a few buttons. Yeah. So what is a container? And apologies if I'm kind of looking down here, because this is where my screen is that's got the slides on, right? But we're looking at a pretty high-level stack, right? We've got hardware, an operating system, and an application. Now, back in the day, we would buy a single physical server, we would install an operating system on that, Windows or Linux, and then we would install an application. So it was kind of a one-to-one relationship, one application per one physical server. And I think we probably all get it that that was kind of a rubbish model, like a bad model. Not only did we waste a ton of resources on each physical server because we would overspec them just so that they weren't underspec'd, but also the kind of time to market for our applications was horrific. So you would come potentially as a developer, if you are a developer, and you would come to operations in some form and say, look, we're about to deploy a new application. Can we have a server for it, please? And there'd be this long, convoluted process where you know, a purchase order would have to be raised to get the server. We'd have to spec it properly. That would have to be approved by finance, sent over to the vendor. The vendor would have to take time to deliver it. You'd have to raise change requests to get it racked and stacked in the comms room or the data center. You'd then have to install an operating system on it. And then after that, you can finally deploy your application. Proper nightmare, okay? Well, kind of saving the day, along came virtualization or VMware. I say VMware just because most people have worked with it, but they kind of brought virtualization or hypervisor-based virtualization to the masses. And what it did was it worked at that very bottom layer of the stack we're looking at, okay, so at the hardware level. So it would take a physical server and it would slice it up into multiple virtual servers. And the important thing about a virtual server was it looked, smelled, and felt exactly the same as a physical server. So instead of physical CPUs and physical memory and physical hard drives and network cards, it had virtual CPUs and virtual memory and the likes. The point being, it was in every respect, even though a virtual machine is a software construct, it looks like a physical server. Okay, on the right-hand side of the slide now, we're looking at the container model. So on the left-hand side at the hardware level is hypervisor-based virtualization. On the right-hand side is container-based virtualization. So we've gone up a level in the stack. So instead of slicing up a physical server, now we're slicing up an operating system. So instead of getting a virtual CPU, we would get like a virtual process tree. Instead of getting a virtual hard drive that needs to be formatted and the likes, we would get in a container a virtual file system and a virtual E0 network adapter and things like that. So it is virtualization of a sort, but it is one level up in the stack. So we're virtualizing operating systems. So on the left, each of the three constructs we're looking at is called a virtual machine. On the right, each of the three virtual operating systems is called a container. Now, importantly, the container model is smaller, faster, and more lightweight than the virtualization model or the hypervisor virtualization model. And the net result is you can deploy more applications per square foot of your infrastructure, whether that's on-premises data center or whether that's a VPC in the cloud. It doesn't matter, okay? Containers are more lightweight, so if you take one physical server that maybe you could install or you could run 10 virtual machines on, you may be able to, and I'm making numbers up here, right? You may be able to run 20 or 50 containers on that same physical server. And one of the big reasons for that, right, was that because every virtual machine in the hypervisor model looks exactly like a physical server, every one of them needs its own operating system installed. So if you take a physical server and you carve it into 10 virtual machines, you then need to install 10 copies of either Windows or Linux. And each one of those operating system instances, so all 10 of them, I never know how to say this, but basically it steals CPU cycles, memory, hard disk space, network traffic from what you would like to give to your application. So if you've got 10 virtual machines and 10 operating systems, that's 10 lots of CPU and memory that those operating systems take away from the solution before you can finally install your application. Now, on the right-hand side, on the container virtualization model, basically because there is only one operating system in the mix in the middle there, and we're carving that up, there's only one operating system that needs CPU, memory, hard drive space before we can install our application. So the net result, right, is that not all, but more and a lot more of the physical resources of the server at the bottom are available to applications in the container virtualization model when compared to the hypervised virtualization model. So that's kind of, that's your sort of primer or primer on containers and how they compare to virtual machines. Now, stepping a little bit away from the infrastructure, I've got one more slide before we take a quick stop for break. So if you have questions about any of this, please ping them in there, and Don will do his best to filter through them and work out which are the questions that we'll tackle now. Anyway, everything starts with source code for an application, okay? So even if you're not a developer, I guess you understand that the process of deploying an application on a virtual machine starts with the application code. Now, we're looking at the container model here, but the process is similar, right? So you start with, we're looking at application code here and the application's dependencies, so any shared libraries and things that that application needs. We package that into a construct called a container image. If you do know virtual machines, it's a little bit like a virtual machine template, okay? From that container image, you can then spin up as many containers as you want, really. But you just need to understand that in that image is your application and all of its dependencies. Now, generally, once we've built the container image, we then store it somewhere in a central repository. We tend to call it a registry, okay? The idea here is when we store our software or our applications, our containers, in this centralized repository, we can apply things, well, look, not just role-based access control to protect our software, but we can also do advanced things like scan our images for vulnerabilities and things like that, which we may come to later. But basically, it's a centralized place that we can then deploy that container to, or we can deploy that software to all of our different environments, dev, test, staging, production, things like that. So that's the model. Take your application code and dependencies, package it as a container image, store it somewhere centralized and safe, and then pull it from there and deploy it to your various environments. And on that, Dom, I'm going to say, if we have questions, I'm happy to take them.
Yeah, definitely. We have a lot of questions coming in, so we'll rapid fire. First question is, how secure is the container as compared to virtual machines?
That's such a brilliant question, and I'm not just saying that, right? So it's something that I could spend quite a while talking about, but broad strokes, high level, right? Out of the box, a container is less secure than a virtual machine, because actually, if I wind the slide back to here, yeah, you can see how every container is sharing a single operating system or a single kernel. And that means that if the kernel of that operating system, or potentially anything in that operating system, is exploited via a vulnerability or something like that, all of the containers that run off of that operating system are also at risk. Whereas the virtualization model, we've got, well, every application gets its own operating system and its own kernel, meaning that if one of them is compromised, it's restricted to that one virtual machine. So out of the box like that, containers are less secure. However, there are different container runtimes. I'm getting a little bit techie here, but there are different technologies that run containers that allow you to isolate operating systems like that in more secure ways. So that's like the big picture, that out of the box containers are a bit less secure, but there are plenty of technologies that you can apply to them that make them as secure and potentially more secure than virtual machines. The challenge that we have, right, is that in order to secure a container, there's a little bit more effort required than there is to secure a virtual machine. But if you have the skills and the time to secure your container environment, it can potentially be more secure than virtual machines. Probably a horrible answer, this, really. Basically, look, I think in the ecosystem, there are tons of technologies that are growing up in and around containers and Kubernetes that give us better insights and better control over our software than we ever had with virtual machines and things before containers, but there's a bit of upfront effort to configure them. Kind of hope that answers the question, because I could talk about it all day and we don't want that.
Yeah, that's a great answer. So there's a lot of comparison questions, Nigel. Yeah. So what are the differences between things like Kubernetes and Docker and Singularity and Airflow? Just maybe pick one or two of those and you know, compare and contrast.
So I'll pick Docker because it's kind of the elephant in the room all the time on presentations like this. So one of the big confusions comes from that, right, so Docker is quite at its heart, Docker is a low-level technology that starts and stops containers. We call that the container runtime, okay? But Docker also has another part of it called Swarm that will orchestrate applications at a higher level. Apologies if you don't know VMware, but if you do, you could think of Docker as like ESXi, that low-level hypervisor that will start and stop virtual machines, whereas Virtual Center sits above that and can manage multiple ESXi instances. Now, Docker does the low-level stuff, and it does the high-level orchestration. So it does the ESXi and the vCenter, whereas Kubernetes just does the vCenter. And it does the vCenter, look, I'm going to say not better than Docker, but so Kubernetes does it at better scale. It has a bigger ecosystem. It has a brighter future than Docker on the orchestration front. So the way that most people would work with Kubernetes and Docker is you would install Docker on a bunch of different servers, and Docker is responsible for starting and stopping containers and things. And then you install Kubernetes above that, and Kubernetes manages all of those nodes with Docker. And as you throw application workloads at Kubernetes, Kubernetes then says, there's free space on this particular Docker server here. Docker, please start and run this container for me. So that's kind of, again, the high level. Generally speaking, these days, we use Docker to do the low-level stuff, and we use Kubernetes to do the high-level orchestration, which is a buzzword, but we're going to talk about it in the next section. Does that answer it, do you think, Dom?
Yeah, no, definitely. Maybe we can take one more question and move on. There's a lot of questions, so we may not get to all of them, but good. I want to make sure we get through the rest of your slides too. So one more question. How do containers manage memory and other resources compared to virtual machines?
Right, okay. Assuming that I understand where the question is coming from, so generally speaking, most container runtimes will use, and I only really know it in the Linux world, though there are equivalents in the Windows world, but they just leverage standard Linux primitives like control groups and namespaces and a bunch of other technologies that will allow you to say, impose like requirements and limits on the amount of CPU and memory a particular container can consume. As in, like, you're running on a physical server at the end of the day, and if you run 50 containers, it's not great if one of them hogs all of the resources from that server. So things like control groups and the likes, which are pretty much industry standard technologies in the Linux world and equivalents in the Windows world, they are leveraged to stop any one particular container running away with all of the resources from the physical infrastructure below. And Kubernetes kind of further abstracts it in the way that you can apply policies and things to every container, which we call a pod in the Kubernetes world, but it doesn't matter. It's effectively the same. So anytime we deploy one, we can have Kubernetes say, this particular one requires this amount of CPU and memory in order just to be able to run, but also we'll cap it at this as a maximum so it doesn't overrun the system. Again, I mean, in these sessions, it's always hard because they're usually good questions like these are that we could kind of do a full hour presentation on. So unless you think I've really made a bodge job or missed the question there, Dom, and feel free to tell me if you think I have, I'll move on with the slides.
Nope, move right on. Thanks, Nigel.
Okay, no worries. Magic questions, by the way, and I love the interactivity. Right, so we've got our heads kind of around what containers are, I hope. What is Kubernetes and why is it important? Because I am going to tell you, it can be a little bit complex at times, although it's getting less complex. But the point is, nobody as an individual or as an organization deploys Kubernetes or any other technology for that matter for the fun of it, right? We deploy these technologies because they bring business benefits. So in order to talk about what Kubernetes is and why it's important, I'm going to at least attempt to bust some jargon. So you'll hear terms like Kubernetes orchestrates containers or is an orchestrator, and it's the OS of the cloud, and terms like microservices and things. So I can already see my next slide coming up, right? Bear with me when I go through this example, all right? So this is a soccer team, and a very badly organized one, I must say at that. But the point is, right, and I am going to bring it back to containers and Kubernetes in a second. But the point is, a soccer team, well, look, and apologies if I fall into calling it a football team, but any sports team is made up, generally speaking, of individuals with different skills and different responsibilities and roles within that team. So, I don't know, a football team here has defenders, midfielders, attackers, and a goalkeeper generally, right? And they have positions on the field. But right now, that's a mess. So if they started a game like that, pretty much they're going to lose. So along comes a coach, and it's the role of the coach to organize the team into something that looks like it's got a chance of at least competing in a game. So we've now got a 4-3-3 formation, 4 defenders, 3 midfielders, and 3 attacking players. Magic. It's the coach's responsibility to organize that, get them all communicating, pick the right people for the right positions. But it's also the coach's responsibility to respond to real-time events. I'm making air quotes on the screen here, but I don't think you guys can see me actually. So when I say real-time events, let's say if we look at the top left-hand corner of the screen, the LW player, that's left wing, okay? If that player gets injured and has to be removed from the field of play, it's the responsibility of the coach to react to that scenario, bring them off, and replace them with somebody else of equivalent skill or of equivalent positional awareness and things like that. So, look, the coaches... Oh, I've gone forward too many. Hold that thought. It's the coach's responsibility to respond to real-time events. Another one might be, this may be a really important game that is a must-win game, and it might be, score might be 3-3 with 5 minutes to go in the game. And the coach may say, oh, we've really got to win this game, so I'm going to switch from 4 at the back and 3 up front to 3 at the back and 4 up front. So again, the coach makes those decisions, responds to real-time decisions. Well, believe it or not, it is exactly the same in the microservices cloud-native world. This is a microservices application on the screen here, and it's very much like a football team. Actually, the reason that we call it microservices is instead of deploying an application, a business application, okay, with a lot of features, well, look at the ones on the screen, right? I'm trying to show, got web servers, we've got logging, we've got authentication, we've got a database backend, we've got monitoring, reporting. A monolithic application would, at a high level, bundle all of that together into a single application and kind of a single binary, okay? And it meant that if you wanted to either, well, if you needed to patch the reporting system, you would have to patch the entire application, which was quite a risky operation. If you wanted to scale the reporting system, you had to scale the entire application or the infrastructure running the entire application. Not really ideal. So what we did was we said, actually, applications are built of lots of different features or lots of different services. So let's just break all of those services out into their own smaller services that run independently. Well, small service, microservice. So that's where the term comes from. A microservices application is basically any business application that does something useful, but is built or designed and built and deployed and managed in a way where every different little feature that it does is its own application. They all talk to each other over APIs and give that same useful application experience. Anyway, look, it's like the football analogy or the soccer analogy we had before. Lots of different little microservices that do different things, kind of looks a mess. Along comes Kubernetes in this instance, taking the role of the coach, and it organizes it into something that looks like a normal application. Kubernetes is also responsible for making sure that everything can communicate and all of that kind of jazz, right? However, as well as setting things up, Kubernetes responds to real-time events. So let's say up in the top left-hand corner, one of the reporting instances, we're running 2 reporting instances here, or 2 instances of the reporting microservice. So that would be 2 containers. One of them's gone red, it's gone down. Kubernetes is intelligent enough to, but also responsible enough to, replace that with another instance, so another container. It may spin in. So I don't know, let's say one of our physical nodes has gone down and it's taken a reporting container with it. Kubernetes will say, hang on a sec, I'm supposed to have 2 in order to meet demand. I've currently got 1. I'm going to spin another one up on another node somewhere else in the infrastructure, okay? Also, what if it's maybe month end or year end? Again, we'll keep our focus on that top left where the reporting instances are. And demand increases. Kubernetes can automatically increase that demand. It can automatically increase, the number of instances, and I think we've gone from 2 to 5 there to meet demand. And then later on, if it needs to, it can scale it back. So, really cheesy, but Kubernetes is very much like a coach in a sports team. It does all of the organizing of your application and is intelligent enough to respond to real-time events. Things like self-healing, that we've talked about there, automatic scaling, potentially things like zero downtime rollouts, where we can push new versions of an application without incurring downtime, maybe automatic rollbacks if it detects problems. All of that kind of intelligence Kubernetes brings. And we call it orchestration because it's pulling the strings or it's orchestrating your application. Now, what that translates to as well then, or actually, no, I'm switching tack slightly here. So that's kind of what we mean by an orchestrator and by microservices. What do we mean by Kubernetes as the operating system of the cloud? So you may have a mixed infrastructure that's public cloud, private cloud, maybe some on-premises stuff as well. As long as you deploy Kubernetes to your different environments and you write your application to run on Kubernetes, which is becoming the standard in the industry these days, then your application doesn't really care whether it's a public cloud infrastructure below Kubernetes or on-premises infrastructure. Slight variation on this slide, right? I've just picked 3 clouds, right? It could be any. These are just kind of probably the most common ones. But then some on-premises infrastructure over on the far right. As long as you've got Kubernetes there, like I said, your application doesn't care if it's AWS, if it's Google, if it's Azure, if it's on-prem. And the reason we call it the operating system of the cloud is, if you think about it, if you were to replace AWS and Google and Azure and what have you on this slide with whatever, right, a Dell server or an HPE server or a Supermicro server or whoever your favorite server vendor is, right, and then you would install an operating system on top of that, Windows or Linux, your applications pretty much didn't care if it was a Dell or an HPE or a Supermicro, right? They just cared that it was the right kernel version in Linux or Windows. So effectively, Linux or Windows abstracted the infrastructure below. Well, in the same way, Kubernetes abstracts cloud and on-premises infrastructure so that as long as you write your applications to run on it, it makes it super easy to balance across multiple environments, to migrate between environments. Small print applies. Of course, it's not always point and click, but that's kind of the premise there. Kubernetes is a great abstractor of modern cloud and on-premises infrastructure. And again, Dom, I'm going to take a little swig of water, check my clock here, and we can take a few more questions.
Yeah, definitely. There's a lot of questions around how pods are communicating with each other when they're inside of Kubernetes. What's the isolation like? How can they talk to each other? Can you maybe talk through that a little bit?
Yeah, sure. So I'm just going to high level here and say, when we talk about a pod, just because it's jargon that I've not covered yet, just think of it as analogous to a container, okay? It gets a little bit more advanced than that in Kubernetes. Of course, I'm aware of that. But generally speaking, when I talk about a pod, just assume a container. So we have this, I'm going to wind the slide back, actually. Bunch of microservices here. We've got 5 reporting instances up in the top left-hand corner. That'll be 5 pods. And I'm showing that they're talking to some middleware there somewhere, right? Okay, out of the box in a Kubernetes cluster, there's a network that we call the pod network. It's an open, flat layer 2 network, if you know your networking. Out of the box, every pod deployed to that network can talk to every other pod. So if you're talking to your database backend, it exposes its standard network port. Another microservice within that application on that same pod network, on that same Kubernetes network, can consume the instances of that database backend just by connecting to its port like it would on a general network that's not on a Kubernetes cluster. So normal networking principles apply. The pod network that all of your pods get deployed to is open, flat, layer 2 network. Now, that's brilliant, but it's shocking from a security perspective. So network policies and other things come into play that effectively let you filter what kind of traffic, drop traffic, what's allowed, what's denied, and get into all kinds of detail there. So generally speaking, you break apart those applications. So that monolithic application that was the web server and the reporting and the logging and the monitoring, all deployed to a single physical server or a cluster, and generally speaking, communicating over shared memory, named pipes, Unix domain sockets, things like that on a server. All of those different parts now communicate over the IP network to an API endpoint, generally speaking. Now, what that does mean is that your east-west network traffic is like much more than it was before. So you need to cater for that both from like a performance perspective, but also from a security perspective. Like I said before, you've got lots of things that we're talking over relatively secure shared memory before, now talking over the IP network. But also because we've split all of the features of applications out into their own pods here, and every pod has its own IP address, you kind of, the dynamic nature of IP addresses coming and going on a network now, on that Kubernetes pod network, is crazy compared to what it used to be, you know, back when we would manage IP addresses via a big honking static spreadsheet. No way we can do that these days. We've got so many things on that pod network, each with their own IP addresses, all talking to each other now. It can be scary, but the tooling and stuff is really starting to mature around that, to the point where we really shouldn't be afraid of this. The benefits it brings outweigh the challenges. Dom, is that like 103 questions that we've got? I've just glanced at the Q&A box.
Quite a few. I'm trying to encapsulate them into multiple questions into one, just so we can get through more of people's questions.
Mate, your job's harder than mine today.
Can you talk about some best practices when it comes to deploying applications in Kubernetes? Like how many containers should I be having running in my pod? You know, like what are some of the other things that I should adhere to as far as Kubernetes best practices?
Yeah, I mean, look, that's a properly good question, and it's one that we could talk about for days, actually. So I'll give a few, okay, that I think are probably like the top ones. Look, I would say, first of all, before you even embark on this, it's vital that you understand that the changes that a microservices architecture brings. And like, I'm waffling before I answer the question, really. But in this architecture, we don't ever log on to a container or a pod anymore if it's broken. We never SSH onto it and fix it live. Like, the whole mindset of how we deploy and manage these things. If something breaks in production, we roll a new version of it and roll that new version out over the top of the old version. We don't log on and try and fix things. So you kind of have to get your head around that as the first best practice, right? So don't go into this not knowing the impacts of the architectural changes that you'll need to implement. But then I would say, look, if you are serious about doing this in production, and certainly if you're a larger organization that takes security very seriously, I would say that you want to look from day zero, if possible, at coupling a service mesh into the game, because a service mesh brings you all kinds of enterprise features like great visibility into that east-west network traffic that we talked about there, better control over your network traffic flow optimization, but also it can encrypt the traffic that automatically flows between pods on this network. So end-to-end encryption without having to build that into your application pods. It does it by inserting another container, a sidecar container, into your pod. Well, generally speaking, that's how it does it. But it just brings so much. So I would say, like, if possible, a great practice is to at least be thinking about deploying a service mesh alongside Kubernetes from day one. Other good practices, it's just getting your head around microservices applications, 10-factor applications. I'm having a brain freeze there, actually. But just the changes that it brings, because you can't, the step change between going from physical servers to virtual machines was relatively small compared to going from virtual machines to containers. And I should maybe have said this earlier, but we could take legacy applications, and I don't mean that in a bad way, okay? And we could take legacy applications from physical servers and lift and shift and just drop them onto a virtual machine. It would work great. You kind of can do that with Kubernetes and containers, but you really, 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 really shouldn't. It's not what it's for. You really need to refactor your applications, break them apart, and redeploy them like this, and the benefits are tremendous. But it's a learning curve. Really, Dom, I'm waffling on that. The list of good practices depends on environments, and it's so... I don't want to daunt anybody by saying it's so long, because it isn't. Look, at the end of the day, it's things like... Look, I'll give you one more as an example. We kind of touched on it before. Somebody asked about how do they take care of memory and CPUs and things. I would say from day one, okay, deploy your Kubernetes pods with resource requests and limits against all of them. because it gives the Kubernetes scheduler so much more visibility into what's actually going on in your environment. Without doing that, I would say the scheduler is almost blind. It doesn't know what is being consumed on each of its nodes that it's managing. So go with the service mesh if you can, and just try and do things like resource requests and limits and those kind of things from day one.
Awesome. Maybe we'll push on for now, Nigel, and I'll source some more questions and take another stop.
So I almost feel like saying, stop putting the questions in, but that's never good. No, really good questions and lots of them. Cracking audience, by the way. All right, let me just advance these slides. All right, Kubernetes new. Look, some of this I'm going to talk about, what the impact of Kubernetes has on organizations and then individuals. And there's actually a lot of overlap. But from an organization or a company perspective, right, if you're a company or you're a hiring manager or a team leader or something like that, the advantages of you deploying Kubernetes are you can bring in the best people. Now, please let me caveat that. In no way am I saying that if you don't do containers and Kubernetes today, you're not the best people, because actually I'm pretty sure you are based on the questions you're putting in. But more and more, the best people are gravitating towards, well, I'm going to say the best technologies, but also the technologies that have the brightest futures and the most growing ecosystems around them. And that just happens to be containers and Kubernetes at the moment. So as time marches forward, and I'm getting philosophical, pretty much the people that you will want to hire and bring into your teams will be looking for projects that involve containers and Kubernetes and organizations that are on board with containers and Kubernetes. It lets you as an organization ride the wave as well. And just think about this, right? If you as an organization or as a team or whatever, right, did not get on board with virtualization and you were still deploying one application per physical machine for your entire environment, certainly, think about where you would be right now compared to your competition. You would be spending and wasting more capital than them. Your time to market would be far worse than theirs. You wouldn't be sweating your assets like they are. So you would be just effectively behind them. So as an organization, there's another wave that's riding, that people are riding at the moment. It's called containers and Kubernetes. Yeah, we get that, right? If you don't ride it, because that step change between virtualization and containers is bigger than between physical servers and virtual servers, you will find yourself behind your competition like you would have if you hadn't adopted virtualization. Only this time, you will be a lot further behind them. So really, you need to be getting on board with this if you want to stay relevant as an organization. Look, it's not for me to say what your organization needs to do without knowing more about your organization, but generally speaking, that is the trend. And basically, you're also future-proofing anything that you build today. So if you're building your applications and things today, and security, for example, is becoming more and more important, if you're not building around containers and Kubernetes, then the tooling to be able to inspect what you've got in your repositories, but also what you're running in your live environments, and actually, so a great thing that has cropped up around containers and Kubernetes has been this ability to do deep-level scanning of your software, so of your container images. Basically, the ability for software or tools to look into your software, your container images, and list out every single piece of software that you've got in that image that might be running in production, right? And to say, give you a report that says, okay, the version of glibc or whatever that you're running in this container actually has a known vulnerability that's of the severe level. And then, so to have that visibility in the first place, we generally don't have outside of containers and Kubernetes, but then the tooling to be able to roll a new version without that vulnerability and roll it out without downtime to production. That kind of tool set and stuff just doesn't exist outside of Kubernetes. So if you're building outside of containers and Kubernetes, you're not going to get the benefit of all of this great tooling that is out there now, and more is coming as we go forward. So I think those are really my three main things about adopting this stuff and the importance of this stuff as an organization. Now, for you as an individual, for your career, look, I'm not going to lie, it's pretty similar. So you're going to get the better roles and the better jobs, because likewise, it's kind of a vicious circle. While the best people are looking for jobs that or projects that build on containers and Kubernetes, because that happens, the best organizations out there notice that wave. They start deploying containers and Kubernetes and wanting people that have those skills. So it's kind of a cycle. If you really want to be getting those 95% of the time, I'm going to say, and that's finger in the air, okay, because I get it that we've still got mainframes and iSeries and AS400 stuff and big Unix, HP UX, that's all still out there, but less and less of it. More and more, we're getting the good stuff, the good project going to containers and Kubernetes. Future-proof your own career as well. Like, just again, not just getting the best jobs and stuff, but on the money side of things as well. I would say, and again, I'm not a career advisor here, right? But there's a real lack of people with these skills and with the experience. So it's just, generally speaking, a great career move. Now, flipping on to our last thing, all right, getting started with Kubernetes. I'm not going to lie, like, it's just never been easier. Okay, so on the slide, actually, sorry, I was looking at the camera there. So yes, of course, there are books and things out there. These are mine. They have got fabulous reviews, so I am led to believe. Of course, I would say this, right? But people do tend to like them. So they're a great starting point, especially, look, if you know nothing, Quick Start Kubernetes, I think it's about 100 pages, about 16,000 words. You can practically read it in a day. But that will walk you through taking some software, simple software, building it as a container image, storing it in a repository, starting it as a pod on a Kubernetes environment, testing self-healing, scaling it up, scaling it down, doing a rolling update. You'll get all of that out of 100 pages of a book. And that gets you to the point where you're then brave enough to be able to take your own steps afterwards. The Kubernetes book is like 400 pages and about 75,000 words. So it's quite a bit of a bigger beast, but goes into a lot more detail. Then I've got tons of videos. Like, if you like this kind of a session where it's a little bit more jovial, we can have a bit crack, a bit of fun. I've got a ton of video training courses on Pluralsight. Just search my name. But the thing is, right, I think the hands-on is the key, and the books and the video courses and things all support the hands-on. Like, you know, they're organized resources that get you started, okay? But I say this a lot, and some of you may have heard me say this, and some of you may have heard me say it several times, because I talk about this stuff all the time, right? But we live in a golden age of learning new technologies. Like, when I was learning Novell NetWare and Windows NT4, especially when I was studying for my Windows NT4 MCSE, my Microsoft Certified Systems Engineer certification, I had to go and beg my boss, and I got on really well with my boss at the time, for a couple of PCs and one of those really ancient monitors that like weighed about a ton. And I had to rig it up in the corner of my bedroom, and it took like 3 hours, 4 hours for me to build an NT cluster. I would play around with it, effectively break it, and it'd be 3 or 4 hours to build it again, and it was a pain. And my wife hated the fact that it was in the corner of the bedroom, because every time I powered it on, you know, the fans spun up and it made the corner of the room hot, and it was noisy. It was horrible. And whereas these days, you can get a Kubernetes cluster that looks, smells, and feels like a production cluster almost on your laptop with tools like Docker Desktop, Rancher Desktop, Minikube. There's even more out there. A bunch of the cloud platforms even offer you Kubernetes clusters in their free tiers. But I will warn you, a lot of these free tiers do mature into fee-paying tiers. So just do always be careful about that. The cloud can cost money, and a lot of it if you're not careful. But my point is, right, the combination of tools like books, video training courses, and the ability to get hands-on experience has never been easier. I'm at the point where, like, you literally have, honestly, no excuse not to get your hands on these days. And if you're passionate about technology, and I get it that not everybody is, right? For a lot of us, it's just a job. But in order to get those best jobs and things, and those best roles, you need the skills. It's just never been easier to skill yourself up. Like, you really don't have an excuse not to anymore. And on that, I'm going to open it to Q&A. But you know what? I'm going to kill the screen share just so that, like, I don't know, I just feel like it's a bit more interactive if you can see me on screen. So I'm open to questions now, Dom. I take it you can see me now, yeah?
Yeah, I can see you. I turned on my video too, so we can have a dialogue here.
Mate.
But
good.
So a lot of people are asking. There's a lot of companies. We've got a monolithic architecture today. What advice can you give to companies who are trying to move in the direction of Kubernetes and they currently have like this monolithic type architecture?
Yeah, sure. So don't be afraid, right? Because most organizations that are already on their journey in containers and Kubernetes started from where you're starting. And they've gone through not all of the pain, because you still will have a bit of pain. Any kind of change that brings something good generally involves a bit of pain. I'm going to caveat it with that. But we're at the point now where it's not like super, super hard to do. Like I used to think in the early days, you kind of needed a small army of Linux kernel engineers on staff to be able to do some of this stuff, the basic stuff. But it's much easier now. But what people tend to do is they will, and I may be, preaching to the choir for some people here, okay? But they will take a small team of individuals from the organization, generally speaking, people that are willing to take on a difficult task. The forward thinkers, those that like to live a little bit on the bleeding edge. And they'll form them into, for want of a better term, a SWAT team or something, who will then take an application, and usually a simple greenfield application to start with, and will roll it out using containers and Kubernetes, and will learn a bunch of stuff as they do that, right? They'll make a bunch of mistakes, but they'll document stuff as they go. They'll do that with the first application. They may, and this depends on your organization and team structure, go on and do one or two more to sort of hone their learning. But then it will be on their shoulders to go and take this new way of doing things to the wider organization, but small steps, okay? So not immediately jump from that to like the crown jewels of the organization, your main line of business applications. Kind of park those for later, but take something simple that's hopefully greenfield at first, get that up and running. Then practice migrating not practice, but take something that's not super important, migrate it or part of it to containers and Kubernetes. Generally speaking, starting with stateless components of that application. Because although Kubernetes most certainly does do state or persistent data, it just is a little bit more complex and it comes a little bit further down the line. So just take lots of small steps with kind of, this is not necessarily the greatest term, but an elite team of people. Have them learn it, make the mistakes, get it documented, and then get them to go and take it to the wider organization is a sort of general picture that a lot of organizations take.
Awesome. Thanks, Nigel. Can you explain what a service mesh is and what role does a sidecar proxy play?
Yeah, okay. So kind of high level, Kubernetes does do a bunch of stuff, but a service mesh, generally speaking, comes along and gives you more professional networking in a Kubernetes environment. So like I think I hinted at before, it gives you way more telemetry, so more visibility into what's going on with your network traffic. Gives you more control over it and more ways to optimize it. But another killer feature of a lot of service meshes is that it just gives you out-of-the-box end-to-end encryption between all of your pods that are talking to each other. And we did say before that because we're breaking up our monolithic applications into lots of small moving parts that are all talking east-west over the network, lots more devices on our network, all with their own IPs, all talking, sending potentially sensitive application data over that network instead of over shared memory now. So that ability to encrypt it out of the box. And I say out of the box because by deploying a service mesh at a high level, right, you have a pod that is running your application container. And the service mesh injects a sidecar or a proxy container in there that basically intercepts all of the network traffic that goes from your application out of the pod to the network. The service mesh proxy container intercepts it and applies or exposes all of this advanced functionality. And the killer feature for me is that the service mesh or that sidecar proxy just does it. You don't have to go to your application developers and say, you know, as part of that refactoring of the application you're doing, any chance you could just build in some encryption and decryption stuff into there? You don't have to do that. Your application developer just writes their application and is blissfully unaware that the service mesh will automatically encrypt the traffic that comes in and goes out, and will automatically provide to a dashboard and stuff all of that kind of visibility. So names like Istio and Linkerd are probably the two of the more, certainly Istio, of the more popular service meshes out there. Now, again, there's a learning curve to a service mesh, but it's getting easier and easier all the time, like it is with Kubernetes. Hope that helps, Dom.
Brilliant. So let's say that I'm trying to get ahead in my career and I want to convince my employer that I am a master Kubernetes orchestrator, person. What sort of certifications would you recommend I go and get, or what should I learn?
Yeah, so I'm going to tell you something. The first thing to do is, right, and I will say this always, right, never lie about your experience. And what I mean there is, like, the standard joke in the Kubernetes community has been people saying that they've got 10 years of experience with Kubernetes. Of course, it hasn't been out for 10 years. So, like, don't do anything silly like that. So what I would say is, if you have zero experience with containers and Kubernetes, it may be more beneficial for you to get maybe one or a couple of cloud certifications first as a sort of foundation level for you. Because, look, certifications are more than just being able to go to an employer and say, here, look what I can do. It's also about skilling you up. And if you are super new to all of this stuff, some of the fundamental cloud certifications might be a good foundation before you jump onto Kubernetes. But then once you get to Kubernetes, it has its own raft of certifications. So there's a brand new one that's just in beta at the moment, but expected to be announced as GA at the end of the year, the Kubernetes and Cloud Native Associate, the KCNA. That's the entry-level one. But then there's Certified Kubernetes Application Developer, CKA, no CKAD, Certified Kubernetes Administrator, CKA, and there's a security one as well. So there are a bunch of Kubernetes-specific certifications that I think have quite high value in the market today, especially because there's a shortage of skills. So that's my thinking around that.
Great, thanks, Nigel. We're getting close on time here. I'm going to try to fit in a couple more questions. What are the differences between Kubernetes as an architecture and a serverless architecture? Are they compatible? Like, when should you use which? What are your thoughts there?
Yeah. So what I would say was, and I'm not a serverless expert, right? But the architectural differences are more between containers and serverless workloads, okay? In that, a serverless workload is a lot more event-driven. So it will spin up. So generally, quite often a serverless workload is actually a container, but it's not a long-running one. It spins up and spins down based on events in your environment. The comparison with Kubernetes, it's a great question, by the way, don't get me wrong, doesn't quite work like that, because Kubernetes, although it orchestrates container workloads, Kubernetes can actually orchestrate virtual machine-based workloads, and it can orchestrate serverless workloads as well. So Kubernetes is like more of a higher-level tool that pulls the strings most of the time for container workloads, but it can pull the string for serverless workloads, and it can pull the strings or it can orchestrate virtual machine workloads as well. So just think of it as a higher-level sort of orchestrator, like we talked about before, that can orchestrate containers, virtual machines, and serverless workloads. That's high level.
Awesome. All right, maybe we can fit in another one. A lot of people want to know about persisting data in Kubernetes. Like, how do you accomplish something like that?
Yeah, so there's a few ways of going about it. And I will say, I think I hinted at it before, that the persisting of data, generally speaking, and this is not a containers or a Kubernetes thing, it is harder, but it's also much riskier. Like, if the network goes down, and I say this a lot, right, it all hell breaks loose, yes, but the network comes back up and things tend to find themselves. If storage or your persistent data store goes down, the potential risks of losing data are far, far greater. the chances of you losing customers and you as an individual maybe losing your job, if the persistent data side of your application goes down, is higher than like the network side. So because of that, and this isn't just containers again, like we saw it in VMware, that it did the low-hanging fruit of stateless compute first, then advanced networking came, and then more advanced storage came later down the line. It's been the same with containers and Kubernetes. But 2020 was a huge year. Like, yes, it was a bit of a shocking year globally, right? But it was a good year for persistent data in Kubernetes. Like, the primitives and things there matured a lot to the point where Kubernetes does a great job of persisting data. Now, we haven't got time to go into it because it's such a big topic. But the container storage interface, so the low-level plumbing that allows you to plug in things like, and I'm just picking household names, right, NetApps and EMC arrays into Kubernetes clusters, matured and are great now. But also in the cloud that plug in like Azure files and plug in Elastic Block Store and stuff from AWS, plug all of those resources and have them exposed to applications on your Kubernetes cluster. Super mature now. So low-level things like the CNI, but also higher-level abstractions like stateful sets that allow you to build your own persistent applications on Kubernetes are far better than they used to be. I'm probably giving a rubbish answer to this because really I can't go into how you do it in the amount of time that we've got. I do cover it a bit in the Kubernetes book. I don't cover it at all in Quick Start Kubernetes, but my book, the Kubernetes book, covers stateful sets and has chapters on persistent storage and stuff as well. Yeah, like I've saved my rubbish answer for that one, really. But basically, go on.
I was just gonna say, definitely go check out Nigel's book for the answer. But I'm afraid we've run out of time for today. There's a lot of questions that we didn't get to. I know Nigel will have access to the questions after, and I'm sure he'll try to reach out and answer as many questions as he can that we didn't get to today. I'd like to thank Nigel again for this very informative presentation, his insightful answers to all these many questions, well over 100 questions. Special thanks to each of you for taking the time to attend and participate today. The talk will be recorded. It will be available online in a few days at learning.acm.org. You can find announcements on upcoming talks and other ACM activities also at learning.acm.org and acm.org. Also, please fill out the quick survey where you can suggest future topics or speakers. Somebody actually requested you do a talk on Docker as well, Nigel, so maybe you can come back. And you can see the link on your screen for the survey. On behalf of the ACM, Nigel Poulton and myself, Dominic Holt, thanks again for joining us, and I hope you'll join us again in the future. And this concludes our talk. Thanks so much.